Okay, so this section we're going to call 8.2, and it's going to talk about a specific quadrilateral to start here called a parallelogram. So what is the definition of a parallelogram? Okay, there are a couple key parts to it. First of all, it's a quadrilateral. What that means is quadrilateral. What that means is it has four sides. That's a term we'd like you to be familiar with. Okay, where... Okay, this is key here. Both sides, I'll say both pairs of sides. Actually, I'll say both pairs of opposite sides. It's probably the more precise way to say it. So both pair of opposite sides are parallel. I'm going to use our parallel symbol for that. Okay. Now, here are some other ones that we'd like you to know. All right, so I think you kind of know it. Parallelograms traditionally drawn like this. Okay, that's a pretty ugly picture. But these two are parallel, these two are parallel. You probably are familiar with this shape from before. Just to emphasize some of the other properties, right? The first one is that opposite sides are congruent, which I think we know, right? So that side's congruent to that side. The other one is, it's interesting, maybe is opposite angles are congruent. Okay, so this and this and this and this, okay, which I think kind of makes sense. Now, here's one, consecutive. If you remember the words consecutive, we talked about that word before, that means next to. Consecutive angles are supplementary. So that means these two angles here add up to be 180 degrees. And if you remember from the last section, all of the angles of a quadrilateral add up to be 360. So that side's 180. Obviously, this side would be 180. Obviously, these sides would be 180. So any pair of next to angles are supplementary. Now, here's the other one that we need to go over that's probably new, is the diagonals. Oops, sorry. Let me erase that. I can't write here very good. Is that the diagonals bisect each other. So that's a term from the past. You remember what bisect means? That means that it goes through the midpoint. Okay, so I kind of muddled up that picture there, but let me show you on this picture here for number one. All right, this is a diagonal because it cuts across, and this is a diagonal because it cuts across. And if it bisects each other, let me try that one again. Okay, what does that mean? Okay, it doesn't mean that they're congruent or anything like that, but what it means is that it goes through, this is the midpoint of both, which means that's equal to that, and that's equal to that. That's what bisect each other means, and we need you to be able to do that. Okay, let's apply this then a little bit, okay, to some problems. That's basically what we're going to work through here, is using those four properties to do it. So if we look at number one, right, if this is 15, let me kind of highlight what this is here then. This is 68, if I'm looking at that right, and 15 and 8. That's really all we need. So if that's the case, what is AD? Do you agree that AD is also 8? Because if this is 8, this is also 8. How about DC? Opposite sides congruent, it's going to be 15, right? It's going to be the same as that across from it. How about angle A? If this is 68, let's go get the easiest one actually. Do you agree that angle B is also 68 because opposite angles are congruent? How would I find for the other one, going back up here, they are supplementary. So how do you find this? Right, I would take 180 minus 68, and I'll tell you that that's 112. Once I determine that A is 112, C is also 112. Okay, so that's how you would go through that one. Opposite sides congruent, opposite angles congruent, and consecutive angles are supplementary. All right, let's look at number three. Number three, we'll try to put this together, okay, with all the givens. What would UT be? I'm hoping you can see if this is 27, this is 27, okay, because opposite sides are congruent. How about ST? If this is 18, what would this be? It would also be 18. Now, let's get to the diagonals here, right? So what does bisect each other mean? That means, again, this is congruent to that. This is congruent to that. So that's something we'd like you to know or remember or internalize. So what would VS be? If this is 7, this would be 7 up here. Okay, and what would VT be? Okay, VT going this way Oh, let me highlight this here quick. I couldn't see it to start. Let me get rid of this thing so we can see it. What they tell you here is RT is equal to 30. So the whole length is equal to 30. So does that make sense? If this is the midpoint and this whole length is 30, what are each little piece? Each little piece would have to be 15. Okay? So let's try to look here at number 5 and see what we can do. And then we'll just look at an algebra 1 or so. So number 5 has a lot to it. So when you get one of these, again, if you can draw your own, you can label. I'm going to do the best I can to label everything. So we have xy is 15. We have wx is 22. Now, this zx, I'm going to highlight these two. The zx is 32. So that's this whole diagonal going from here to here. Okay, the other diagonal, WT, this time they give me W to T, is 10, so I need to deal with that. Now, then they give me some angles. So WZY, okay, so WZY, that would be this angle here, right, is 62, that whole angle. WXT, this little angle here, actually, WXT would be 27. Okay, and then they tell me ZWT, WXT is 27, yep, and then ZWT, I'm trying to follow this here, would be 77, so this little piece here is 77, okay, all right, now there's a lot to that, so let's see if we can come up with some stuff, all right, so some of these are pretty simple, I guess. The first one being this angle, this XW, because this is 15, this is going to be 15, so pretty simple. For the next one there, right, for ZY, what would this be? If this is 22, this is 22. I think that's pretty simple. How about TX? So for TX here, right, I got to go back up here, and if ZX is 32, okay, so from here to here, what would each one be? Do you see that TX would be 16, okay, for that one. And then here, if WT is 10, so this little piece here is 10, what would this piece be, right? WY. Oh, the whole thing. So if this is 10, this would be 10, right? So what is WY? 10 plus 10 would give you 20. So a little bit tricky there. All right. Now this next one here says, what would TZY be, right? So TZY, if it came down here and went like this, okay, if we go through that one, we'll come back to that in a second here, okay, for that one. But let's take a look at it here. I guess I can do it now. If we understand the parallelogram idea, so don't forget that this side's parallel to this side, okay, and then here's 27. This little, here, let me do a different color. If this is 27, I don't know if you remember this or not, but there's something called alternate interior angles, okay, that right there, TZY, is also going to be 27. All right, how about XYZ? So XYZ would be this whole angle here. Okay, so for that one way we could do it is if this is 62, how could I go about finding those two to find that one? Do you agree that this one could be 180 minus 62? Right, and if you do that, I should get 118 for that one. How about XWT? So XWT would be this angle up here, okay? So if we have that one, all right, what would that be congruent to, okay? And one thought to think about it is if this is 118 now, I found this to be 118, that means this up here also has to be 118. So if this is 77, how would you find little part? If I would take 118 minus 77, a little tricky to get that little piece up here in the corner, okay? What would that turn out to be then? That would turn out to be 41. That one's a little tricky. And then for this one, how about XYT? Okay, this angle here. Now I got kind of ugly here, but let me try to get rid of some of this stuff up here. Okay, if this was 77 and I'm trying to find this one, how would we look at it again? Alternate interior angles. This one would equal that one. So that's also equal to 77. So there's a lot there, but what did we do there? We looked at consecutive angles being supplementary, and then what we did is we took the pieces related to the diagonals and used alternate interior angles to relate them. Okay, so number 6 is kind of the same. Now, down here, all that's going to happen here for the second part is they're going to ask you to put things together here algebraically. All right, so let me see what we need to go over here. Let me look at these top. I'll just set these up quick, and then I won't do them all here. So what's true about these two? This would be equal to that. So how would this be set up? 9x minus 25 equals 5x plus 7, right? So, and I'll let you solve that. For this one, if TV, okay, if this length here is 74, and WV is 4x plus 1, okay, how would I put that together? Do you agree that 4x plus 1 either times 2 or another one, right, because it goes through the midpoint, all of that would equal 74. Does that make sense? You could accomplish the same thing by doing this, okay, and you would solve for x. All right, what would be true here? This angle would equal that angle, so you'd set them equal to each other and solve them. All right, let's look here then at number 13. That's a little bit trickier, and this kind of reinforces something, and then we'll stop the video here. So if KLH, so this whole angle here is 134. Okay, now what I want to try to do is solve for x. So I got to figure out that. So if this is 134, I guess here's something we need to come up with, a little tougher. I need to look at these two. So what's true about those two? Those two angles are supplementary. So if I took 180 minus 134, if you can follow me there, okay, if I do that first, actually, let me calculate that quick. All right, so if I take 180 minus 134, I'm going to get 46. So one of the concerns here then is if that's 46, okay, what would this little piece be? Because here's what I know. That little piece is equal to that little piece for alternate interior angles. So what could I do next? I could take 46 minus 25, right? So if I would subtract that, I would get 21. All right, so that's a long way to go to say then that 4x plus 9 equals 21. Okay, for that, so if I would subtract that, subtract 9, I would get 4x. I'll finish this one up for you then. I would get then 4x equals 12. And I would finally get x equals 3. So that one's a little bit tougher, maybe a little beyond what we're going to ask on a test, maybe not, as one of the advanced questions there. But there was a lot going on there, yes? So I figured out this missing angle using the supplementary part, and then I used alternate interior angles to get that. So that's the most challenging one. Okay, so that sets the stage then for what I'd like you to do. Tomorrow we'll talk about this, or the next day of class we'll talk about it. Yep, and set you loose on the